Hello there, Mr. Sutton here, bringing you the Algebra 2, Chapter 3, Quiz 2 Review Solutions on Quadratic Equations and Complex Numbers, Part 2. This one focuses on using the quadratic formula, quadratic systems, and quadratic inequalities. For this problem, they want us to solve this using the quadratic formula. So let's start by getting this in standard form, which means we have decreasing order of exponents and 0 on one side. Now there's two ways to do this. The fastest way would be to just subtract 10 over to the left side. That unfortunately leaves us with a negative x squared, which is kind of annoying to deal with in the formula. Not insurmountable, but I prefer a positive square term. So what I'm going to do is add x squared over to the right side and subtract 6x over there. That gives me x squared minus 6x plus 10 equals 0. Not the only way to do it, but I like how this works out in the long run. So here's our quadratic formula. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. So our b value for this b part here is going to be this negative 6. So that's going to be negative 6 plus or minus the square root of negative 6 squared minus 4 times, we have an invisible 1 here, times the c value of 10, all over 2 times 1. So this is going to be positive 6 over 2. And then inside we have the 36 there, minus 40. So that comes out to negative 4 inside there. Now the square root of negative 4, since it's a negative, we have to take out an I. And then square root of 4 is 2, so plus or minus 2i for that piece of it. And we have to reduce this if we can. 6, 2, and 2 are all reducible by 2. So this ends up being 3 plus or minus 1i, or just plus or minus i. On this one, they're telling us to use the discriminant to determine the number and type of solutions of this equation. So the discriminant is just the stuff that was inside the square root for the quadratic formula. So discriminant is just b squared minus 4ac. This is already in standard form, so I can just plug in a, b, and c into this formula. So we've got b squared, so that's 16 squared. And then we have minus 4 times 4 times 18. And I'm just going to run this on the calculator and see what it comes out to. So plug in all that in, we got 16 squared minus 4 times 18 comes out to negative 32. Since negative 32 is, well, negative, less than 0, that tells us that we're going to have two imaginary solutions. If we had gotten exactly 0 for the discriminant, that would have meant one real solution, and if we had a positive discriminant, that would have meant two real solutions. To solve this system of equations, there's a couple of approaches we could take. One would be, since I have a negative y and positive y, I could just add these two equations together right off the bat. That would cancel out the y's, and we'd have x squared minus 17x equals negative 70. That would be a pretty quick one to solve. Another way to do this would be to use substitution and get maybe this y by itself in the second equation and then substitute it into the first equation. That's the approach I'm actually going to take, but either one of these would work just fine. So to get y by itself, I have to subtract x, and then I can replace the y in this first equation with this 11 minus x that I've got here. So I've got minus parentheses so I don't forget anything. So this is going to be x squared minus 18x minus 11 plus x equals negative 81. To go a little bit further in this problem, we're going to get this thing in standard form, zeroed out when in doubt. So let x squared can just stay on the left side here. And then negative 18x and 1x gives us that negative 17x that we could have gotten by just adding these together. And then finally, negative 11 plus 81 gives us a positive 70. This looks like it could be factorable. Two things that multiply to 70 and add up to negative 17 is what we're looking for. So we've got 1 and 70 won't work, 2 and 35 is no good, 5 and 14 I think is not going to work either. 7 and 10 works if they're both negative. So x minus 7, x minus 10 equals 0. So that means that x equals 7 is one of our answers. Now we actually do have to plug this back in to get a y value that goes with it. When you're solving a system, you're getting a point, an x and a y value. So let's plug this into, I think just this 11 minus x equation is going to be our best bet. So we have y equals 11 minus 7, which is 4. So we have 7 comma 4 as one of our answers. Now back up here, x minus 10 equals 0, so x equals 10 is another branch of this solution. And then plugging that into the 11 minus formula here, so we've got 11 minus 10 giving us 1. So that means 10 comma 1 is our other solution. For this next problem, which is in the Algebra 2 non-honors version of the review guide here, we're trying to graph this inequality. So we basically have to graph this like a regular parabola, only we may need dashed lines and open dots if there's no equals on the inequality, which as we see here there is no equals, so open dots and dashed lines. We're also going to have to shade one direction or another based on this inequality, but we'll get there when we get there. Let's start by graphing the quadratic. So because this is standard form, I'm thinking negative b over 2a is a good way to start this. That'll give us the x value of the vertex. So that's going to be negative 4 over 2 times negative 1. This is 4 over negative 2, which comes out to negative 2. And then plugging that back in to get the y value, we have negative 2 squared minus 4 times negative 2 plus 3. So this is negative 4 plus 8, which is 4, and 4 plus 3 gives us 7. So negative 2 comma 7 is our vertex. And then just graphing that, again, we're going to use open dots because there's no equals on the inequality. So negative 2 up 7. Let's see, we got 3, 4, 5, 6, 7 right there. Now, this 3 here is the y-intercept, so that's another easy point to use, 0, comma 3. That's right here. And we can use symmetry over the axis of symmetry to reflect that y-intercept over here to negative 4, comma 3, giving us our third point. So we have a dashed line going through those open dots. And now for shading, we have y less than, so we're going to shade below, lower than the curve. That's going to be everything underneath this parabola. And this is our solution. For this problem, which is the problem on the honors version of the review guide here, we're just graphing the solution set for this system of inequalities. So we have to essentially graph each of these separately and then just shade where they overlap. This first shape is actually a line, not a parabola. So we can just graph this in y equals mx plus b type of reasoning. We have a y-intercept of 4, and because there's no equals on the inequality, that's going to be an open dot. So open dot at 4. And then our slope is negative 1 over 2. So we're going down 1 over 2, another open dot, and a dashed line through the open dots. Now because this is y greater than, that means we're going to shade above that curve. So that's everything up here. It's getting a certain type of shading. And now we move on to graphing this quadratic, which is going to be a parabola shape. So because this is standard form, I'm going to start with negative b over 2a. That's going to be negative 4 over 2 times negative 1. So that's 4 over negative 2, which is negative 2. Plugging that back into all of this stuff, we've got negative 2 squared is 4, and that becomes negative. Negative 4 plus 8 becomes positive 4, and then add another 3 in there, we get 7. So negative 2 comma 7 is the vertex for that one. Now because there's an equals under this inequality, we're going to use a solid dot at that vertex and all the other points that we do for this particular inequality. So we've got negative 2 comma 1, 2, 3, 4, 5, 6, 7 right up there. There we go. And let me get the y-intercept as well. That's going to be 3. So that's right here. And symmetry allows us to get a third point over here. And there's our parabola. Now, because we have y less than or equal to, the equals doesn't really matter for this piece, but because we've got less than, that means we shade below this shape. So that's everything underneath the parabola. and just looking for where we're overlapping. It's this little piece here at the tip of the parabola, so I'll shade that a little darker, and that ends up being our final answer for this one. On this problem, we're trying to solve this quadratic inequality in one variable using some algebra. So we're going to find the x-intercepts, or the zeros or roots, however you want to call them, and then we're going to use a little sign analysis around those on a number line to give us the shape of this solution. So I'm going to pretend that this equals 0, and I'm just going to solve it like a normal quadratic. This looks like it's factorable. Two things that multiply to -8 and add up to 7. Let's see, we have 1 and 8, and that'll work if it's -1 and +8. So we have x minus 1 and x plus 8 equals 0. So we have x equals 1 then, and -8 zeroes out this other factor. So I'll put those on a number line. Now because my original inequality was no equals on this, it's just less than, not less than or equals, I'm going to use open dots for where I mark the place on my number line. So I've got an open dot for -8 somewhere over here, and another open dot for 1 somewhere to the right of that. We're not being super specific with grid lines or whatever. As long as they're in the correct order, we're good. At this point, we're going to test a x value from each of these 3 different sections that I've broken this up into with my roots here. And then we'll see if that makes this factored version positive or negative. So let's try out something less than -8, like -9. -9 minus 1 is negative. -9 plus 8 is also going to be negative. So that comes out to a negative times a negative, which is a positive. Now for something between -8 and 1, I think 0 is a good one to use. 0 minus 1 is negative. 0 plus 8 is positive. Negative times a positive is a negative. And then finally something bigger than 1, like 2. 2 minus 1 and 2 plus 8 are both positive. Positive positive gives us a positive product. Now the original inequality was less than. So we just want to shade in the negative pieces of this then, since we're less than 0 for that original. So that's just this region between -8 and 1. And to get the actual answer, I just have to write an inequality describing what I just graphed here. So this would be -8 less than x less than 1.